So first of all, we are going to talk about the bubble sort algorithm. So in the bubble sort algorithm, we do simple comparisons for the adjacent elements. It repeatedly compares the adjacent elements. For example, if we do the iteration, then we will be comparing 5 with 1, then 1 with 4, then 4 with 2, and then 2 with 8. All right. And if the elements they are in the wrong order, then what we do is basically we are always comparing the adjacent elements if they are in the wrong order. For example, here you can see that the 4 should come after 2. So what we will do is we will simply swap them. Okay. So this process will continue till all the list elements are completely sorted. What we will do is you can see here we have 5 different elements in this example. So what will happen is in the first iteration, the element which is the largest is going to go in the last, and the element which is second largest here, which is 5, it will go to the second last position, and the element which is the third largest will go to the third last position, and so on and so forth. This whole array will get sorted. So I'm going to do a dry run for this algorithm. What will happen is that first let's do the first pass, meaning the first iteration. Okay, so in the first iteration, for the first time, what we are doing is we are comparing 5 with 1. Okay, so 5 and 1 they are swapped. Okay, so now it becomes 1 5 4 2 8. Now now we are on the second element. So here you can see that 5 is greater than 4. So again we will swap, and now the array will become 1 4 5 2 8. Okay, now we are on the third element. Here you can see that 2 is smaller than 5, therefore there will be no swapping. Now if we will look at the fourth element, then we will see that the fourth element, which is also the n minus 1th element, because n is 5 over here, n is the size of the array. So again for this element you can see that the next element is greater, so there will be no swapping. So now we are done with one iteration. Now what we are going to do is that we are going to do the second iteration. In each iteration the last element will get sorted. So this was the first iteration. The last element, which is the 8, or also the greatest element, will is at its correct position, right? So we do not have to look at the last element, we just have to look at the rest of the elements, right? So n minus 1 elements needs to be sorted now in the second iteration. So this is the array now. This is the array in the ending. Now here what we are going to do is that now we are again going to compare 1 with 4, so there will be no swap, right? And in the next iteration we are going to compare 4 with 2, and here we will swap those elements, so it becomes 1 2 4. And we compare 4 with 5, but there will be no swapping since it is already in sorted manner, right? So here in the next step we are going to perform third uh, pass or iteration, right? So in the third pass or third iteration for the whole array, we have performed this already 2 times, right? So the last 2 elements are sorted, so we will perform it for n minus 2 elements. Okay, so for the n minus 2 elements we will be starting from index 0 to index n minus 2 minus 1, which is basically n minus 3 element. Okay, so the 1 and 2, since they are already in the sorted order, we will not swap them, right? Now the 2 and 4, again they are in the sorted manner, therefore we will not swap them, and so on and so forth. 4 and 5 they are sorted, and 5 and 8 they are sorted. Now the array is already sorted, and in the third pass we did not perform a single swap. So since we are not performing a single swap in any iteration, therefore we can stop over here, and we are done with our algorithm since the array is already sorted. And now let's write code for this bubble sort. So sort and array lead code, you can search for this problem on the lead code, and here we're going to write our code. Okay, so now we are going to write our code for the bubble sort, and we will do it with the Python 3. Okay, so let me first get the length of the array. All right, Now we are going to iterate through this array n times, right? For I in range n. Now in each iteration, we know that the last element will get sorted, right? So we have to start from the 0th index to till n minus I minus 1. Why? Because initially the last element will be the n minus 1th, for the first iteration the index for the last element will going to be n minus 1, right? And for the second iteration the n minus 1 element or the last element will be sorted, so it will be n minus 1 minus 1, that is n minus 2, and so on and so forth, right? So what we are going to do is basically we are going to check if ARR J, the current element, if the current element is basically greater than the next element, right? So this is not ARR, this is nums actually. If the current element is greater than the next element, then we need to swap them, right? So nums of J and nums of J plus 1 is basically going to be the same thing but just in the reverse order. This is something you can do in Python. Okay, so it will be J plus 1 first, and this is how you can swap two numbers in Python, right? And in the end we are going to return the nums array. Okay, so I think I need to first log in before running this code. Okay, all right. Let me run this code. The solution, it is correct. Let me also submit the solution. Now this solution is not an efficient algorithm. It runs in the time complexity of big O of n square. As you can already see that we have two loops which are in the range of n, right? So it is running in the n square time complexity, and since we are not using any extra space, therefore it has a space complexity of big O of 1. So here we are getting the time limit exceeded error because it is taking too much time, because the code, it has a time complexity of big O of n square, and this one particular question will require a solution that will run in n log n, since the size of the number is very large. Okay, so this is the bubble sort, and if we want to do a few optimizations, for example, let's say when we for each iteration we can have a variable which is swapped, telling whether an element is swapped or not, right? So whenever we are doing the swapping, what we can do is basically we can set the is swapped to true, and finally after the iteration is over, then we can check if is swapped. If not, is swapped. If there is no swapping, then that means we can directly break out of this loop, because the array is already sorted. So if I submit this, then again I'm expecting a time limit exceeded error, but apart from that I'm not expecting any sort of wrong submission. So here I can see that the 10th test case has not passed. Still, the 10th test case has not passed because it has a time limit exceeded error. But the solution is accepted. That means we have the right solution. Also, one thing I forgot to point out is the range function. It takes two arguments. The first one is included, but the second one is not included. So the loop will go from 0th index to n minus 1 minus I minus 1 index. Okay, so the last element will be n minus 2 minus I. So for the first j I equals to 1, this is going to be from 0 to n minus 2. Okay, so that is because j plus 1 should be less than or equals to n minus 1, since n minus 1 is the last possible value for the index for this list. Since it has n elements, therefore the range of the indexes is going to be from 0 to n minus 1. Okay, so that is why this second element is not included, and which is why we have this instead of n minus I. Because if we do something like this, then the this array will go from 0 to n minus 1, and n minus 1 plus 1 will be n, and nums of n is going to give us an array index out of bound error. Okay.